let's work with Cassie for starters. How much money does Cassie start out with?
2,500.
No.
Oh no.
1,250. Okay. How will I figure out how much money Cassie will have in the bond after 1 year? How will I figure that out? Can somebody help me out?
You do 1.04 times $1,250.
Can you say that? I'm going to turn up my volume, and I want you to yell it as loud as you can. Can you say it one more time?
You do 1.04 times 1,250.
You did a very nice job of making that very loud. Okay, great. So for year 2, all I have to do is add $50, right?
No.
No.
You multiply by 1.04 again.
Oh, so I multiply that previous value by 1.04. I am. How about for year 3?
Multiply by 1.04 again.
Okay, so I multiply that same amount by 1.04 again. All right. So are there any questions on how to make this table really quickly and efficiently? Okay. Lastly, we're talking about dollars and cents, so you should keep decimals to the dollars and cents, so 2 decimal places. Does that make sense?
Yeah.
Of course it makes sense. All right, so I would like you very much to head off to your what is, actually, Caleb, could you help me out? What is the value of Cassie's money after 10 years?
1,850.31.
And Abby, what was the equation that you got?
N equals 1,250 times 1.04 to the y power.
So it's tough for me to write on the board when it's this low. To the which power? To the y power.
Yeah, hard to say. Y power.
Okay. Could someone, I'll take a volunteer. Abby, could you please pick that volunteer? What about for Kaylee?
Harrison.
Harrison. All right.
Okay, so for the 10-year.
Let's start with 1, 0, 1, 2.
Oh, okay.
And then we'll
So for 0, I had $2,500.
Okay.
And then 1, I had 2,600.
Okay.
2, I had 2,704.
Okay.
4, and then should I go to 3 or just go to 10?
Let's just go to 10.
Okay, for 10 I had 3,700, or 3,761 cents.
And Harrison, could you pick a volunteer for the equation? A girl this time.
Alyssa.
Okay, Alyssa.
Okay, so I said that it would be 2,500 times 1.04 to the x power equals y. Or, sorry, it would be 1.04 to the y power equals n.
Okay. All right. So what is the same about these two equations? What is the same about these two equations? This is not a trick question.
Well, you've got Abby and Harrison and Josie raising hands.
Josie, what is the same about these two
They're
growth factor, or the 1.04?
So their growth factor is identical. So they have the same growth factor. Okay. So what's different about these two equations? Somebody new.
Gigi.
Gigi.
They have a different y-intercept.
They have a different y-intercept. Okay. Has anyone noticed a connection between the money for Cassie and the money for Kaylee?
Gavin.
Gavin?
The money for Kaylee is pretty much always double the money for Cassie.
So Kaylee is always twice Cassie. So are they earning the same amount of money?
No,
No.
No.
Who's earning more money?
Kaylee.
Kaylee. Kaylee's earning twice as much money as Cassie. Who's doing more work? Cassie or Kaylee?
Neither.
Neither.
What do you mean neither?
They're not doing any work.
They're doing nothing. So they're doing nothing and Kaylee's earning more money than Cassie. Is that inherently fair?
No.
No.
No, so you're saying that's not fair.
No.
Raise your hand if you think this is not fair, if you all agree that this is not fair.
Not fair at all.
Is about 100% of people saying it's not fair?
95.
Almost everyone. Okay. So we're going to take a closer look at this not fairness tomorrow. However, before we get that, so just because Kaylee started with more money, she's earning twice as much money as Cassie. Her money's increasing twice as fast as Cassie. So here's one thing I would like you to do really quickly. I would like you to go to the internet, and yes, I need you to do this before you leave, so don't not do this. So go to the internet. Oh, hey, it's everyone's faces. This is so much fun. And I would like you to go to a site called Desmos, D-E-M-O-S, DESMOS.com. Desmos.com is the Desmos fun. All right, so...
You got some smiles in that.
All right, so we are going to go to the graphing calculator. I want you to go to the graphing calculator too and hit graphing calculator. And we're going to type in our equations, and let's see what happens here. And I'm going to zoom out a lot because obviously we're dealing with the thousands. I'm zooming out by, yeah, that's probably good. Okay. Maybe zoom in just a little bit more. Okay, there we go. All right, so our first equation was, and we have to use y and x's, so y is equal to, all right, and that was that was times 1.04, and now I need to use this little thingamajig right here because I want to do it to the power of x. And then I'm going to hit enter, and I'm going to type in the other equation. Y is equal to 2,500. Use the same growth factor. And I'm going to use this button again to get my exponent, x, all right. So now I have these two graphs, and I can barely see anything. All right. So what do you notice is happening with these two graphs? I know it's pretty hard to see right now. What's happening with these two graphs?
We're all looking closely at the graphs. No hands.
Now, so I can go to a custom. I'm going to a custom grid. So really, I just want to see. Come on. And so let's go up to 4,000. There we go. And so here's the graph. Just go out just a little bit. There we go. All right. What do you notice about this graph? Any observations you see at all? And it might be easier if you're looking at mine.
It's growing exponentially, and the blue line is growing at a more rapid pace than the red line.
Right. So notice how that difference, the difference between Kaylee and Cassie's money, is constantly increasing. It's always getting bigger. The difference, the inequity of it all. So that is something that we are going to discuss tomorrow in a little bit deeper. And again, to get the grid to show up to something that's a little more reasonable, I use this little wrench tool, and I set the X and Y settings to something a little more reasonable. All right, are there any questions for today's work?